Okay, keep in mind that what we're focusing on right now is still probability, but probability when the outcomes aren't equally likely. Now we're working with fractions. So Lewis works in an office and his phone rings occasionally, and the possible number of phone calls he receives in the afternoon and their probabilities are given in this table below. So 0 calls, there's a 1/6 chance that he's going to receive 0 calls that afternoon. 1 call, 1/6, 2 calls, 2/9, so on and so forth. Okay? It doesn't change because these are fractions. Okay? Excuse me. If I were to make these all into common denominator, if I look at 6, 9, and 3, they have a common denominator of 18, right? So if I go 6 times 3 to get 18, I'm not saying you have to do this right now. And 1 times 3, that would be 3/18, right? If I took the other 1/6 and made it into 3/18, and I'm just showing here that they add up to 1, like I've said, okay? 2/9, if I go 9 times 2, I have to go 2 times 2, and I get 4/18. 3 times 6 and 1 times 6 would be 6/18. And 1/9 again times 2, that'd be 2/18. All right? So if I add 3 plus 3 is 6, plus 4 is 10, plus 6 is 16, plus 2 is 18. Guess what? That's 18/18. And what is 18 divided by 18? 1. Okay, so this one, again, like I said, they all add up to 1. Okay, probabilities have to add up to 100%. Okay? Okay, so find the probability that Lewis receives 3 or 4. 1/3 plus 1/9. Now, we do have to have a common denominator, okay? So if I look at 3 and 9, they have a common denominator of 9. So 3 times 3 is 9, 1 times 3 is 3, so 3/9 plus 1/9 equals 4/9. You can divide that, but it's going to be some type of decimal. So again, we'll just leave it as 4/9. Don't worry about the decimal, okay? Be careful again of the words they're using. Fewer than 2. So fewer than 2 would just be, like if here's 2 right here, right? Fewer than 2 would be 0, 1. So that would be 1/6 plus 1/6. We don't need a common denominator because we have one. That's 2/6. Now you don't have to change it to a decimal. Okay, this would be a repeating decimal, but we probably should reduce it. Both 2 and 6 have a common factor of 2, so I can reduce that into 1/3. Excuse me. Okay, notice how close this next one is. Find the probability that Lewis receives 2 or fewer. This one was fewer than 2. This is 2 or fewer. So in this one, we're going to include the 2. So we have 1/6 plus 1/6 plus 2/9. Okay, do need a common denominator for this, and that's 18 again. Okay, and I've actually already changed them here. If our denominator is 18, 1/6 is 3/18 times 3 times 3, the same thing. 2/9 is 4/18. 3 plus 3 is 6, plus 4 is, 3 plus 3 is 6, plus 4 is 10. Hello, 10/18. Dividing both of those by 2, that would be 5/9. Now, find the probability that Lewis does not receive 4 phone calls. So we want all of these except 4. Well, if we want all of them except 4, we can just subtract. Remember, they all add up to 1. We can just go 1 minus 4, 1/9. Now, you can look at that and say, hey, that's 8/9. Or you could say, hey, 1 over 1 can be written as 9/9. That's the 1. 9/9 minus 1/9 is 8/9. The other thing you could do is add up all 4 of these, finding a common denominator. So if that doesn't convince you to use the idea of that everything adds to 1, if we don't want one of them, we can just subtract it off. That makes it a little quicker and easier. Okay. The diagram below shows the spinner designed to look like the face of a clock. So we have a red section. That's this right here, right? We have a blue section. If it's like a clock, remember, we have each of these little dots are 12s, right? We have a green and a yellow. Look at that, I have those colors. Perfect. So we want to write our answer as fractions in lowest terms. Find the probability that the pointer stops in the following colors. Here's the problem. They're not equal sections, but we can make them equal sections. Because this is a clock, I can make this into 12 different sections. We can divide it equally. We can't just say there's 4 sections because there's 4 colors because they're not the same. But if I break them up into 12 equal sections, then we can just say how many of each color they are. Why I colored it. So red, there's only one red section here. So that would be 1 out of the total number, 12. Blue, how many do we have there? 1, 2. There's 2 out of 12. Now it does want it in lowest terms, so I'm going to divide top and bottom by 2. And I get 1/6. Green, should have maybe done this in those colors, but that's okay. Green, there's 1, 2, 3, 4, 5. And there's no common factors there, so we have to leave it as 5/12. Yellow, 1, 2, 3, 4. Well, 4/12. They both have a common factor of 4. If we divide it out, we get 1/3. Sorry, that was very sloppy down here. 4/12 divide, maybe it's going to be better, by 4. Sorry, guys. There we go. All right, so these are fractions in lowest terms. 1/12 of the circle is red, 1/6 of the circle is green. It's blue. 5/12, almost halfway, is green. And you can see that almost halfway. And 1/3 of it is yellow. All right. Oh, let's fill that into our table here, right? Red, 1/12. Blue is 1/6. Green is 5/12. And yellow, see if we'll see that, is 1/3. Okay, sorry, that one's pretty light. Find the probability that, now we're going to use this going on here, that the pointer stops in either the blue region or the green region. Here's what I want you to do. See this word or right here? Plus sign. Blue is 1/6. Green is 5/12. If it can be in either of those, either or, you add them together because it doesn't matter which one it falls in. Okay, so we have that whole group to do. So you can put them, you can just add them together. We do need a common denominator. Common denominator is going to be 12. So 6 times 2 is 12, so 1 times 2 is 2. 2/12 plus 5/12 is 7/12. And we don't have any common factors, so we just leave it. Find the probability that the pointer does not stop in the green region. So we can add 1/12 plus 1/6 plus 1/3, or we can go 1 minus the green, 5/12, which is 12/12 minus 5/12, or 7/12. All right, main purpose there, don't be intimidated by fractions. We do everything the same. We just use fraction operations, right? What we know about that. Probability doesn't change, even when they're not equally likely. Outcomes in the event divided by total. Sometimes we're going to have to add more than one probability together. And the big thing here is if we want everything but one thing, you can go 1 minus that, because probabilities always have to add up to 1 when you're talking about all the things in a sample space.